Alright, welcome back to Mr. P Helps with Calculus. This is Unit 4, Day 2, and we're still doing some position, velocity, and acceleration by looking at graphs, kind of like what we did on that last video. Alright, when is the particle moving to the left? Well, once again, as we talked about in the last video, it's moving left anytime the velocity is negative. Now, what is very important with these questions is, what kind of graph are you looking at? This is a position graph. Position over time. So your position is moving to the left if your position is getting less. So we're looking at the slope of this graph. So if your position is at 20 and then your position becomes 10, obviously you're moving to the left. Okay? So now knowing that, if this is a position graph, so that would be the two green times. The green ones are going left because it's going down. Your position is going from 0 down to -3, where your position was going from 2 down to -6. All right, red. When is a particle moving to the right? It's moving right anytime your position is increasing. So if you go from -3 on a timeline to 2 on a timeline, you must have gone right. Same thing if you're looking at an x-axis, that's the way to look at this. Forget the fact that this is a graph, right? So this is position changing over time. So that happens to be the velocity, change over time of position. So if you go from -6 to -2, the only way you, and this was 0, the only way you can get from this position to this position is by going to the right. That's why it's in red. Hopefully that makes a lot more sense when you think about this. This is position change. This is how position changes over time, which technically is velocity. So anytime it's going up, that happens to be positive velocity. Anytime it's going down, it's going to be negative velocity. What is the particle at rest? What's staying at rest is when the position doesn't change at all. So that just makes a lot of sense. That's the 4 of them, sorry. The 4 times that the position did not change. All right, when is the particle moving to the left? Well, this is velocity change over time. This is velocity. So anytime the velocity is above the x-axis, we know it's going to be positive. This is positive velocity. This is the velocity of 1, velocity of 2, velocity of 2, 2, 2, 2. Then it goes back down. It's still a positive velocity all the way until it hits the x-axis. When is a particle moving to the right? Well, it's moving right. Well, I'm sorry, that's what I just went over. When is a particle moving left? It's left anytime it's below the x-axis. So anytime your velocity is a negative number. Negative velocity means going to the left. Once again, if you think about this in a number line, if the velocity is -3, that means you're like, if you're at -1 and then here's -3, so that's how much you are moving in 1 second. And then you move -3 again, although that's actually only -2, but you get my point. So over time, you're just moving further and further to the left anytime your velocity is negative. When is the particle at rest? Well, it's at rest at these yellow points, which happens to be when it's at 0. 0. Now, there is some debate about the way these two is kind of like an instantaneous. These are obvious, points of rest, and so is this. But these two is just when it's switched. It's like a momentary, it's not even really a time. It's just an instant when you were at rest. The only way you can move right and then start moving left again is there has to be a split second. And this is all theoretical where you weren't moving at all. But it really didn't happen over any amount of time. All right. A particle moves along the horizontal line such that a position at any time over 0, that makes sense. How could time be negative? It's given by this function. It's measured in feet and measured in seconds. Okay, so we're doing kind of the same thing we just did. We just practiced there a second ago, which is what we did on the last video. Find the equation of velocity. Well, the velocity is simply the rate of change of position. So that's why we have derivatives. So the derivative of t, s prime t, which is position, the derivative of position is equal to the velocity. And that would be just the derivative of this. That's the instantaneous rate of change, not the average rate of change. Those are two completely different things, which you're going to find here in a second. This is probably the most highly missed question right here. B, find the equation of the acceleration. Well, acceleration would just be the rate of change of velocity. Or you could say the rate of change of the rate of change of position. Yes, you are expected to write this on the AP exam. You'll have to say that second derivative of position equals first derivative of velocity equals acceleration. It's the rate of change of the rate of change, because velocity is the rate of change of position. Acceleration is the rate of change of that rate of change. Well, in this case, it's 2 because it's the derivative of this. See, I'm not really focusing on the math. The math is pretty easy. You should already know your rules for finding derivatives. Find the displacement. Well, displacement, in this case, remember, is your just distance from the distance change from where you ended and where you started. So after 2 seconds, where did you end minus where did you start? That's it. So you're basically just plugging in 2 into this equation, plugging 0 into this equation, and then subtracting those 2 answers. That's how much you're displaced, how much you've changed over time. So remember, displacement can be negative. It's displacement, it's total distance that can't be negative. Find the average velocity during, okay, so now average velocity, this is where people get tripped up. They see the word velocity and you think that that means you've got to do v of 4 minus v of 0. But no, think about this. Average velocity is the slope formula. That's that y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You're doing change of position of y over change of position of x. That's literally what velocity is. Velocity is the slope formula. It's your change of y over change of x. And that's literally what I did here. So don't get thrown off. When you see average velocity, make sure you use the position. 9 times out of 10, this is the most common made mistake on people's tests and exams. Find the instantaneous velocity. Now, the key here is the word instantaneous. That alone tells you you're using derivatives, not average rate of change. Two completely different things. Instantaneous rate of change could change over, like, if you want to find the average rate of velocity over the first 4 seconds, from 0 to 4. Now, could your instantaneous rate of change been different over that time interval? Yes. Average rate of change just means your average from here to here. Instantaneous could have been changing the entire way from start to finish. So basically you just put 4 in for a velocity graph and that's it. That's it. The key here is knowing that instantaneous means use the derivative. Use the velocity derivative, which you already used up here. And by the way, on the AP exam, you don't have to refine things. If you already found the derivative in A, then you can just use that equation that you found in A. By saying v of 4, you are now telling the person who is grading your paper that you know that that's what it's represented by this equation, which you've already stated. If you don't put v of 4, then and you just show this work and you show it getting the 4, you're going to get a point taken away because you have to say why this equation is being used. The reason why this equation is being used is because it's v of 4. You don't have to re-show that this is how you find the derivative of a velocity. You don't have to say v of t. Okay? Hopefully that clears that up. Find the acceleration. So once again, you don't have to redo this. But you do have to say that it's a of 4. You do have to say, well, that's why you're using this equation. Which, let's be honest, the answer is 2 no matter what. No matter what this number was, the answer was going to be 2. All right, when does the particle change direction? Or when does the particle at rest? Well, you know a particle is at rest when the velocity is 0. So you take your velocity equation, which you found in part A, you set it equal to 0, and you solve it using... This is usually easy math when you get to this kind of question. When does the particle change directions? Okay, now, the key here is it only changes directions if it changes from a negative to a positive velocity or a positive to a negative. Now, I'll be honest, I feel like on H I should have proven that, and I didn't, probably because I was trying to save some time, like I am right now. So you should kind of, plug in v of 1 and plug in v of 3 just to make sure that it really did change signs, because it is possible that it could have hit 0 velocity and then gone back to going right again. It is possible, as we've talked about in a prior video. These are very similar questions. I'll go a little bit faster, but I'm going to go through one more. I'm not going to do more than this because due to time constraints. But it's a very similar format for these questions. Find the equation for velocity. Remember, velocity is the derivative of position. You must state this. This has to be here. So just use your rules for finding derivatives. It's just power rule. Then acceleration is the derivative of its velocity, which happens to be the second derivative of position. All of this needs to be stated. Displacement, remember, is just where did you end up minus where did you start. It's how much distance. It's not how much total distance was traveled. It's just where did you end up, where did you start, subtract them. That's it. Average velocity. Don't fall into the trap. Again, remember, Average velocity is your change of position over time, over change of time. It's essentially just the slope formula. It's not change of velocity over time. Change of velocity over time is acceleration. Don't do that unless it said average acceleration, but I don't think they ever ask you that question. Find the instantaneous velocity. Remember, instantaneous is not average velocity. Then you're using the derivative. Very key distinction between these two questions. Find the acceleration when t equals 4. Just plug that into your acceleration. Once again, you don't have to resolve for these using power rule. You can just say a of 4 and say the answer. When is a particle at rest? You know a particle is at rest when velocity is 0. Just simply solve for it. When is a particle changing directions? Well, I guess for this question, we're just going to assume it's changing directions at this point. But really, I feel like in the future, it's going to be necessary to solve for 0, solve for 1 second, and make sure that it really does change directions over that time interval. Because as I mentioned before, it could at 0 seconds be moving right. At 2/3 of a second, it could be that instantaneous standstill, and then it goes back to moving right again after 1 second. All right, thanks again for watching. I think this video is a little bit easier to understand than the last video. And I did kind of already go over the last video in the very beginning. So very good video, hopefully. And thanks again for watching. I'll see you in the next one.